Hi guys, welcome to my channel. In this video, I'll be covering monolithic architecture in DevOps, microservices architecture in DevOps, and then I will explain architecture rules of thumb in DevOps. Guys, I have uploaded complete DevOps subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share, and subscribe to my channel. Let's get started. At first, I will explain monolithic architecture in DevOps. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front-end, back-end and database, all these are tightly integrated into a single code base, which means everything is kept together within a single folder. Guys, I will give one example so that you can clearly understand this definition. Guys, any application contains front-end, back-end and as well as database. For example, I am creating college application. In that college application, total I created 4 pages. One page is student login form, next one is faculty login form, next one is student attendance, and next page contains student results. So in college website, whatever you see, we consider it as front end. So basically I created this front end application by using HTML and CSS. In student results page, whenever I enter my roll number and click on submit, automatically I can see my results. How it happened? Because in backend, I written some code by using programming language like Python, Java, C++. I written some kind of code. So whenever I enter my roll number and click on submit, automatically I can see my results. So in backend, we'll write some kind of code. Based on that, our application will work. And complete data related to this college application like student names, student results, student attendance, complete information is stored in database. So database is used to store information. Whenever you develop any application, if we store code related to front end, back end and as well as database in one place, then we call it as monolithic architecture. For example, I created college application. In that college application, I stored code related to front end, back end and as well as database in one single folder. Then we call it as monolithic architecture. The name itself says monolithic means single block. That is, storing all these components in one single place. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front-end, back-end and as well as database, all these are tightly integrated into a single code base. Single code base is nothing but storing all these components in one single folder. This is known as monolithic architecture. This is diagram of monolithic architecture. Single code base is nothing but storing all these components in single folder or directory. Total there are 3 components. They are front end, back end and as well as database. Front end is nothing but user interface. We can create front end by using HTML and CSS. We call this front end as presentation layer. And next one is back end. Basically this back end contains business logic. In back end, we'll write code by using various programming languages like Java, Python, .NET, so on. So we call this backend as application layer. And third component is database. Database will store complete data related to application. So we call this database as data access layer because we can access data. So these are 3 components. So we can also call this monolithic architecture as 3-tier architecture. In monolithic architecture, front end, that is user interface, and back end, that is business logic, and as well as data access layer, that is database, works as a single unit. So it is easier to manage all operations because all components of the software located in one place. As all these 3 components are located in one place, we can easily perform various operations. For example, I want to get student results. So whenever I enter my roll number in front end, automatically I can see my result. So we can easily manage various operations. In a monolithic architecture, changes made in one layer can affect other layers because they are tightly integrated. Guys, I will give one example. Guys, for example, I created college application. In this college application, I want to add new feature like I want to add new course page. For example, in this course page, whenever I click on CSC button, automatically it should display all subjects related to CSC. So again, I need to write code in backend by using programming language like Python, Java, so on. And again, I need to connect this course page to database. So in monolithic architecture, whenever you change one layer, then you need to change remaining layers too. And there is also another problem in monolithic architecture, that is, for example, if one layer is not working properly, automatically it will affect other layers. For example, due to some error, this backend is not working properly. So whenever I enter my rule number and click on submit, it will not show my results because this backend is not working properly. So if there is problem in one layer, automatically it will affect remaining layers. This is because in monolithic architecture, all these components are tightly integrated into a single code base. For example, I created a college website. In that college website, I want to add a new feature like adding new courses. So whenever I change presentation layer, I need to change business logic layer and as well as data access layer too. Next I will explain advantages of monolithic architecture. As we know in monolithic architecture, everything is stored in one place. So develop, test and deploy becomes easy and communication between these components is very fast. As all components are tightly integrated, developers can easily understand entire application. In monolithic architecture, deploying application is very fast when compared to microservice architecture. Next I will explain what is this microservice architecture. These are disadvantages in monolithic architecture. First one is, it's challenging to update existing ones as the entire application need to be modified. Guys, I will give an example. Guys, this is Kali application which I created by using this monolithic architecture. Guys, for example, in this Kali application, I did one small spelling mistake. Like in login, I did not written I, just I written LOGN. So due to some spelling mistake, I need to change only front end. But as we know, front end, back end and database is stored in one place. So for this small change, again I need to place this complete code in GitHub and then I need to perform build and test operations for this entire application. I cannot perform build and test operations only for this front end. So I need to perform build and test operation for all these components. So it is challenging to update existing ones as the entire application need to be modified. And second one is, a fault in one part of application can bring down entire system since everything is tightly coupled. As I already said before, if there is fault in one layer, it will automatically affect remaining layers. And third one is, as everything is tightly coupled, it is difficult for teams to work independently, leading to coordination challenges. As complete code is stored in one place, then coordination between teams is very tough. So this monolithic architecture is not suitable for large size applications. Just it is suitable only for small size applications. This is all about monolithic architecture. Next I will explain what is microservice architecture in DevOps. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservice architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. Guys, I will give one example so that you can clearly understand what is this microservice architecture. If you consider monolithic architecture, in monolithic architecture, front end, back end and as well as database, all these components are stored in one single folder and they are integrated to each other. But whereas if you consider microservice architecture, in microservice architecture, each service is placed in one folder and they are not integrated to each other. As you know, there will be three components: front end, back end and as well as database. In front end, I created student login form, faculty login form and as well as student attendance. So this application contains total 3 pages. For example, whenever I enter my username and password, automatically I must log into that website. So I integrated the student login form with Java code, similarly faculty login with Python code and as well as student attendance with C++ code. And I connected the student login form with separate database and as well as faculty login form with separate database and as well as student attendance with separate database. Now what I will do is, I will consider the student login form as one service and I will place this entire code in one folder. Similarly, I will consider faculty login as another service and I will place this entire code in one folder. And similarly, I will consider student attendance as one service and I will place this entire code in one folder. And these folders are not integrated to each other. So whenever I perform changes in one folder, it will not affect other folders. So whenever I perform changes in one service, it will not affect other service. For example, in student login form, I done some spelling mistake. So whenever I perform changes, it will not affect remaining folders as all these folders are not integrated to each other. For example, due to some problem in database, I cannot access student attendance. Even though if you cannot access student attendance, You can access student login form and faculty login form because all the services are placed in different folders and they are not integrated to each other. So changes made in one folder will not affect other folders, and also errors in one folder will not affect other folders. This is microservice architecture. First, in front end there will be user interface and there will be multiple microservices. Each service is connected to separate database. I already explained this example. In a college website, each function like student attendance, faculty attendance, student results and college courses, all these are considered as separate services in a microservice architecture. Changes made to one service such as updating the student attendance feature won't affect the other services like faculty attendance, student results and so on. Changes made to one service will not affect other services. So this is definition. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservices architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. In DevOps environment, microservices architecture shines because it allows for better scalability, flexibility and faster deployment and as well as resilience. These are 4 advantages in microservice architecture. First one is scalability. Scalability is nothing but modifying one part of application will not affect other parts, such as updating student results form will not affect student attendance form and faculty attendance form. Similarly, next one is flexibility. Flexibility is nothing but teams can choose the best tools and technologies for each microservice, making it easy to adapt changing requirements. Based on user requirements, developers can update code which is present in various folders, and they can easily update specific part of code because changes made in one part will not affect other parts. So they can easily modify application based on requirements. And next one is faster deployment. As we know, each microservice is independent. So you can easily update only that part of application without affecting entire application. And last advantage is resilience. If one microservice fails, it does not bring down the entire application. The rest can still function normally. For example, this faculty login is not working well. So even though if this faculty login is not working well, it will not affect student login and student attendance. This both will work normally. These are disadvantages in microservice architecture. First one is complexity. Whereas in monolithic architecture, complete data is stored in one place. So it is easy to manage application. But whereas in microservice architecture, there will be multiple microservices in different folders. So it is very hard to manage. And next one is communication. If you want to develop any application by using microservice architecture, then all employees must communicate each other efficiently. Otherwise, you cannot design good application. And third one is monitoring and debugging. As we know, each microservice is stored in one particular location. So monitoring that application and as well as finding errors in that application is very tough. These are disadvantages in microservice architecture. Next, I will explain architectural rules of thumb in DevOps. Guys, rules of thumbs are nothing but they are generally principles or guidelines widely used in a specific area. They are not strict rules, moreover like a practical suggestions to achieve positive results in system design and implementation. Guys, if you want to achieve positive results in system design and implementation, then you need to follow these principles. I will explain all these principles in detail. These are not strict rules. These rules are just suggestions. So in DevOps architecture, if you want to do good system design, then you need to follow these principles. Another first one is modularity. If you want to design any system, then you need to design system in modular fashion. Modular fashion is nothing but breaking our entire software into smaller modules that works independently. Same like microservice architecture. So maintenance and update will become easier. And next one is scalability. Scalability is nothing but if you are designing any software, even though at a time 1000 people are accessing that application must run smoothly without sacrificing performance. Third one is automation. By using various kinds of automation tools, you can automate process like deployment, testing and monitoring application. So work will complete fast and will reduce human errors. Fourth one is resilience. Resilience means building systems that can handle failures by including backup plans and automatic switches. For example, whenever your software fails, then automatically it must take backup and then it must work properly. And fifth one is infrastructure as code. Managing infrastructures like setting to track changes, recreating setups and setup automatically. Sixth one is continuous integration and continuous deployment. In DevOps, by using tool like Jenkins, you can create pipeline in order to perform automatic continuous integration and continuous deployment. Seventh one is monitoring and logging. You need to create monitoring and logging systems in order to check system performance and detect issues early. Eighth one is security. Guys, you need to integrate security practices like encryption, access control, so on in early stage of development and deployment process. Ninth one is containerization. Guys, whenever you develop any application, we will not place our application directly into server. Instead, what we will do is, we will place our application in container and then we will place this container in server. So in order to place application in container, we will use tool like Docker. 10th one is feedback loop. Development team, operations team and as well as customers, they need to communicate each other and they need to take regular feedbacks so they can develop application better.